right, here we go. So at the top, you can tell we have a trinomial here. The biggest exponent is a 3. The difference between what we're doing today and the ones we did on Friday are the first number is not 1. It used to be like the first number on every single problem, it's like x squared plus this, whatever. There was no number in front of your first term. This time there is. So it says before factoring a trinomial into two binomials, go ahead and look to see if you have a GCF. So this blank is a GCF. You guys gonna be all right? I'm recording. You should stop. Thank you. It says AGCF. You've got to also actively listen to do this. And some of us have issues with that in here. We're going to figure out what the GCF is for all three of these numbers, and we're going to take it out first. So the smallest number that I have between the three is a 3, and I'm going to take that out. I know that you can take 15 divided by 3 and 18 divided by 3. So I know that the number that I'm going to use is a 3. They all have x's, but you got to use the smallest one. So this, you can only take one x out. So now we're going to divide each term by 3x. So what is 3x to the third divided by 3x? Well, what's 3 divided by 3? 1. What's 3 minus 1? So you start with an x squared. You could put a 1 in front of that if you want to, but it is not necessary. 15 divided by 3. Positive 5, that's where the plus sign comes from. What's 2 minus 1? Just 1. You're never going to see people putting exponents of 1 there. You just put the one letter there and you're done. Negative 18 divided by 3. Negative 6, and you would have no x's there. So this is why finding a GCF comes in so handy, because now looking at what I have in the parentheses, I can go ahead and do my x factor thing. So only looking in the parentheses now, the last number was a negative 6, so it goes on the top. The middle number was a positive 5, it goes to the bottom. And we want to figure out something that multiplies to give me negative 6, but adds to give me 5. 6 and negative 1. Everything's okay. So you start by writing x. This is a positive 6, so you'd say plus 6. You have another x, and it's a negative 1, so you'd put minus 1. Those are your binomials. You have to attach your GCF to this, because you can't forget that you took 3x out at the very beginning. So you start with 3x, then you write down the two binomials you came up with. If you didn't know how to find the GCF, you wouldn't be able to do it this easily. And I'll show you, because later on we won't have a GCF. All right, it says, why should we factor out a GCF first? Why should we factor out a GCF first? And the first reason is it simplifies the problem. I'm really bad at writing, so just keep that in mind. Guys, stop. Moving on. This is like those two problems we just did. Guys, if we can't focus and can't do this, then I'm going to go ahead and just take this video up to the office and say, listen to how they're acting in my class. This is accelerated. Stop. Find the GCF between 5x squared, negative 3x, and 50. Biggest number you can take out of all of these is a 5. 50 doesn't have an x, so I'm not allowed to take an x out. So all I'm going to do is take out a 5. So I'm dividing all three of my terms by 5. 5 divided by 5 is 1. Most of the time, they're never going to actually write that 1. They're just going to leave the number off. Negative 35 divided by 5. Negative 7, and I have 1x still. 50 divided by 5. Okay, so here is my, I've taken my GCF out. Here is the trinomial I'm looking at, and I'm going to do the x factor with that. A 10 goes on the top, and a -7 goes on the bottom. So something that multiplies to give me +10, but adds to give me -7. Yeah, -5 and -2. So you're going to start, Sydney, I see it one more time, you're going the hallway. 5 starts x minus 5, because that's our first little puzzle piece, x minus 5, and then x minus 2. That's going to be our answer. The last one that's just like this, you do the same thing. You look for the smallest number that you have. I have a 6, a 30, and a 24. I'm going to go ahead and see if I'm able to divide all the other numbers by 6. And I can, so I know the number I'm going to take out is a 6. Oops, I messed up. We can also take out a letter this time. The letter we can take out is just 1x, because the smallest value was right here, x. Now I'm going to divide. If I have 6 divided by 6, I have 1. 3 minus 1 is 2, so this one's just left as x squared. 30 divided by 6 is a +5. 2 minus 1 is just 1x. Last one, 24 divided by 6 is +4, and you have no x's with that. Now I can do my x factor method. The last number inside those parentheses goes to the top. The bottom number is a 5. Something that multiplies to give me 4 but adds to give me 5 would be 4 times 1 and 4 plus 1. So outside of my binomials, I have to put a 6x, and then these are both positive, so I'd say x plus 4, and I would say x plus 1, and I'm done. So that is one scenario. If the first number is not a 1, you can try to find a GCF and try to take that out. There are instances where you don't have a GCF that you're allowed to take out. The biggest common factor that they have is a 1. So we're actually going to skip example 2. We're moving to the back page, so turn there. This is what you do, and you need to be paying attention now because there's a lot of work involved here. If you have a GCF of 1, for example, nothing in common. I have a 6, an 11, and a 4. The biggest thing they have in common is a 1. So if that's the case, there's a specific thing you're supposed to do. The standard form of this equation is ax squared plus by equals c. So the first thing you want to do is identify what letters A, what letters B, and what letters C. In this first equation, the first number with the first term is your A, so it's 6. The middle number with your X is your B, so that's an 11. And your C is the last term, which is a 4. Now that you know what A, B, and C are, it actually lists all your steps out for you, but I'm going to make sure we're clear on them. It says identify A, B, and C. We did that. You're going to multiply A times C. What is 6 times 4? That's going to be the top number of your little puzzle thing. You took A times C to do that. The bottom number is still going to be B, so what's our B? We're looking for something that multiplies to give me 24 but adds to give me 11. 8 times 3. Okay, this is where things change. Okay, so when you have a GCF of 1, you have to start by writing down your very first term. Our very first term was 6x squared. I'm rewriting it. The next thing you're going to write is you're going to write those puzzle pieces you just came up with. You came up with 8 times 3. So you're going to say plus 8, and then you're going to add an x. Then you're going to do the other one. You did 8, now you got to do 3, and you've got to add an x to it. The last thing you're going to write is your last term in your original equation. It's a plus 4. So what you're going to do, now that you have it all rewritten, you got the 8 and the 3 from the X factor method, the answers to your X factor method. You're going to group these at 2 at a time. And you're going to find the GCF between the two things. So we want to know what's the GCF between 6x squared and 8x. What's the biggest number they have in common? And do they have an x in common? So take out a 2x. What is 6x squared divided by 2x? Just 3x. What's 8x divided by 2x? Just a 4. The x's go away. So I did the GCF with the first group, and now I'm going to do the exact same thing with the second group. What do 3x and 4 have in common? They only have a 1 in common. That's all I can take out. So 3x divided by 1 is 3x. Positive 4 divided by 1 is positive 4. You should check your parentheses. You should have the same exact thing in this parentheses that you have in this parenthesis. If you do not, you did something wrong. Okay? It's always going to work out like that, where what's in the parentheses is the same. So now to get your two binomials, you're going to write the two numbers outside the parentheses together. This is 2x, and this is a positive 1. That's your first binomial. And then whatever's in the parentheses, you only have to write it one time, is your second binomial. And that is your answer. So if you have a GCF of 1, and you have a number at the beginning that is not a 1, it makes it a little bit more difficult, but it's just practice. It takes practice. We're going to practice this a lot, and you're going to make sense of it pretty quickly. So the first thing you want to do on number, we're going to do a couple more. I know the bell's going to ring eventually, so we're going to figure out what A is, figure out what B is, and figure out what C is. A is with your first term, so that's a 10. B is the middle term, which is a 17. And C is the last term, which is 3. What you want to do is you still want to do the X factor method like we always have done, but to figure out the top number of it, you want to take A times C. In this case, that'd be 10 times 3. The bottom number is just B, whatever B is. In this case, it's 17. And now we can figure out something that multiplies to give me 30, but adds to give me 17. Yeah, 15 times 2 is 30, and 15 plus 2 is 17. These are going to be reused. We have to use those numbers soon. What you're going to do is you're going to start by writing your very first term in your original equation, which was 10x squared. Then you're going to write one of your two answers. So I'm just going to do plus 15. That was one of my answers, and I have to put an x by it. Then I'm going to write the one that I haven't used yet, which is 2. And I also have to make an x by it. Your last number is going to be the last term in your equation. In this case, it's positive 3. You're grouping the first two together and the last two together. You're going to find the GCF of those two things individually. So what is the biggest number that 10 and 15 have in common? And can I take out an x? Do both of them have an x? So I do that. That's the GCF between those two. What's 10 divided by 5? And 2x, or x squared minus x to the first is just x. What is 15 divided by 5? And I would have no more x's because they only both have one x, so 1 minus 1 is 0. Now I'm looking at my last two. They have nothing in common except for the number what? 1. They have a 1 in common, that's it. If I take 2x divided by 1, I still have 2x. If I take 3 divided by 1, I still have positive 3. So the last thing you're going to do to get your answer, you write down the first terms outside the parentheses. So you have a positive 5x and you have a positive 1. Those go together now. So it's 5x plus 1. The second binomial is what you have in the parentheses. And once again, you should note that this thing in parentheses and this in parentheses are exactly the same. If you don't get the same exact thing both times, you did something wrong. You need to go back and check your work. That'll be what we end on today, you guys. We'll keep these and finish them up tomorrow.